can only improve what you can measure. Well, first, I think the key word in that question is retrofitting, which is really important because most buildings already exist. So we don't have the luxury of designing from scratch, where we choose the right building material, we make sure everything's sealed off correctly, we have dynamically controlled air conditioning with the right zoning required. We could do all of that in a brand new building. But bringing this back to retrofitting, I think the important thing, and this is obviously biased coming from an integration platform, but to get everything integrated. So if we start to tie in all of the endpoints that consume energy, all of the energy systems, the HVAC system, which is the #1 culprit for energy, and then everything else from audio-visual to desk power, anything else you have into one system to normalize data, put it in a way that is comparable. So part of normalization is taking units of measurement and putting them in the same units, simple things like that. Getting it into a time series database, which can then interact with interface and automation recipes. Measuring is the important thing there, and then what do you do with that data? So there's white papers from ASHRAE, for example. There's many organizations might have data on this, but there's papers on what the indoor air quality should be as a standard for different environments. So there's a standard for office environment, for example. I can't remember the data off the top of my head, but let's say humidity has to be between 30 and 50%, something like that. So if you measure that, you can benchmark against it as one thing, but more importantly with PlaceOS, we can take that as an input condition to set automation. So if it falls outside of the recommended standards, we can trigger an alert, a maintenance request, or even better, we can change the set points of the air conditioning to try to adjust for the low air quality readings. I think with the retrofitting, you have a huge opportunity, because if you're not introducing a lot of new hardware, we can just start improving efficiencies that equal energy savings, which equals return on investment immediately. We actually bring budget back into the solution that you can spend on additional energy saving projects. So for example, if we just start with HVAC, as we know, collectively it's usually about 40% of the energy bill. All the studies are anything between 25% to 40%, but it's a big energy savings if we can make it more efficient. We also know there's a lot of wastage. So when it comes to retrofitting, that's the first point. How do we use real-time occupancy data to dynamically control HVAC and lighting and audio-visual, anything else we can immediately connect? You'll start getting hundreds of thousands of dollars of return on investment, which we could then use to invest in the next phase. It could be something physical like sealing off certain parts of the building so the air is managed more effectively. It could be investing in solar panels that we then monitor the energy coming in versus the energy coming out to continuously improve the return on investment. So there's a number of things, but I think the starting point retrofitting is finding the quick win, and that's solving your wastage problem from efficiencies that we can add. The easiest way there is to calculate the CO2, and when you have that, you can either look at the CO2 savings or your total CO2 usage. And with everyone aiming towards net zero at some point, everyone has different timelines for this. Either your own internal corporate policies, your ESG targets might set a certain decade to be net zero, or your government might be mandating it in a slow rollout towards net zero, or at least a certain milestone that you need to hit. Carbon offsetting is an option. It's a messy option. I think that part of the industry is starting to improve, but we know there's been issues with what's actually happening when we buy carbon offsets. But if you know your carbon usage and your savings, you can start to look at those options. I've actually come across some interesting startups here in Australia that do carbon offsetting by growing algae, which is much more efficient than planting trees. That's an option we're looking at PlaceOS. How do we measure our clients' carbon? We could offset it with algae, perhaps. But there's many things you can do there, but measuring, and probably the takeaway message for lots of these energy questions, you can only improve what you can measure. So let's start by connecting everything so we can measure it effectively and not just run off guesswork. A lot of people's CO2 reporting is calculated based on how many employees they have, how many square footage of real estate they have, the average commute time between the house and the office, the commute method. It's all just like rough rule of thumb, but I would rather like to actually monitor the real energy consumption. There's a caveat here. The more data you have, the better, but also the more data you have, the messier it can be. It's really important to normalize the data so it's comparable and can reference and be in context with other systems. So how does your occupancy reference your kilowatt hours used? And the best way to do that is to put it into one system. Again, biased from PlaceOS, but it's exactly the problem we take care of, where we plug it into our time series database so you can start cross-referencing all the things we're connected to.